There's a Zoom link on the website.
Yes.
아, 맞아, 저도 지갑 잃어버린 후 미리 넘긴다고. 실제로 안 좋은 일이 생겼을 때 일보다는 큰일이 생기지 수하려는 마음. 뭔가 태도가 비싼 잠시 후 정보 수집 구간 일리로부터 수정타가 일하면 오른쪽에 15속도로 스펜서 어젯밤 우리 하더니 다른 말로 잠시 후 측정타가
Again, start our class today on time. Is there any question on schedule or other items? No. Can move on to the regular schedule. As today we'll study on underwater systems. Schedule. And I will guide you at the front parts. And then Dajong Gang will review the second part of lecture. And Pierre will guide us to the discussion session. And you will see that on Tuesday next week, there will be a proposal presentation. And also there will be a long break from 28 until 3. We will have 2 holidays, no classes. Then we'll come back on Thursday. Okay. Then I can show you my slide set and underwater system. If you have any question, raise your hand by using option there in the Zoom. You can have the option for raise hand, or you can speak using your mic or other ways. Or chatting is also available. So several ways to raise your question. Right? So underwater system. So we are studying on textbook 2, Ocean Engineering. And this one is about chapter 7 of underwater. Content is divided into 2 parts. I'm covering history of undersea exploration and manned underwater system. Unmanned system will be covered by Dajong. So, history, 16th century, diving bell is coming from Italy. 17th century, there is submarine. I guess there is no power, human powers, or no power at all, submarine. In 18th century, it has a diving chamber, upgraded version of a diving bell. And now, 18th century, after the help, there is a hand-powered submarine. You see on the right hand side blue colored photo that is a person who is using his foot to rotate propeller lock, like device to move. And then early 19th century with a hand-powered submarine also different ideas is coming. And 19th century later part, there is a torpedo, automatic torpedo, first time. A person in picture handling the torpedo. 20th century U-boat of Germany, very famous, and World War One era. And then Second World War gives you many developments, major advances in undersea technology such as submarines, communication, developed. And then during that time, there is a bathysphere. It is developed for exploring deep ocean, deep water. And then the scuba is developed in middle of 20th century by Cousteau and Anand. And then it comes with a nuclear submarine. middle of 20th century. After the World War II, because we already see that nuclear bomb was used in the end of World War II, and the same technology, or modified one, is used for nuclear power. In 1960s, there are also revolutionary submersibles, ROV, and Habitat. 70s, atmospheric dividing system. Atmospheric means the pressure inside the suit or chamber was same as air in the land. And then AUV appeared in say 80s, so that is only less so 40 years ago. AUV. AUV is no tethering cables attached. And then commercial AUV and glider idea is so manned underwater system. Left-hand side is atmospheric pressure, same as on the land. And right-hand side is ambient pressure. Ambient means the pressure same as nearby. So deep water, high pressure. So left-hand side, we see that the submarine, submersibles, that's here, atmospheric suit. The suit is clothes wearing was special, similar to space suit, where there is no pressure, zero pressure, underwater habitat. And right-hand side, with the person have the same pressure as the water depths. It is scuba diving bell. Inside the diving bell, there is air, but the air has a high pressure, same as the water pressure there nearby. So dipping more deeper, more high pressure inside the diving bell, air capturing. And also diver propulsion vehicle, this separate propulsion device, the human. Okay, and then this is a lung, human lung, breathing capacity. You see that maximum lung volume is up to 6 liter higher. And also you see that we use only about 600 milliliter for normal, ordinary breathing. So very small portion of lung is used. Sometimes we use big, deep breathing is used sometimes, not always. So there are many different cases or usage of lung. So for the divers, and also pressure also there, you need to understand what is the usage and volume of lung. And we already see this one before. Deep diving, 12 meters is a recreational diving limit. 18 meter divers with open water certification. And 30 meter is for divers. Recreational diving limit. And then because of the nitrogen narcosis, symptom is coming because of this depth and pressure. We'll see more on nitrogen. This next slide. And then absolute limit is 40 minutes, even if together with the nitrogen narcosis. And then 65, there is a compressed air is used, and oxygen toxicity is coming. And then 150 is record depth for scuba diving, world record. and then 700 is saturation diving depth circle. Oh, very deep, already human deep. And diving hazards, three main problems is carbon dioxide excess, and oxygen shortage, and oxygen poisoning. Okay, it gives you discomfort, disease, and unconsciousness. And the second one, oxygen shortage, the brain will be damaged if oxygen is no oxygen for say 4 minutes. So it is not easy because lung contains air, so that blood is flowing between brain and lungs. So, but anyway, from the viewpoint of brain, you need oxygen uh, provide oxygen uh, at least uh, 4 minutes can be the limitation for brain. Oxygen poisoning is too much oxygen there. Breathing 100% oxygen with high pressure can be very fatal, not good for your health. And there is a breathing equipment. First one is we already see that regulator type, so that high pressure chamber cylinder, and there is a regulator to the pressure is down to atmospheric pressure. And then the other ones are closed or open or semi-closed type, so that the air is circulating inside the device. That is a closed circuit type. But many times the air used one is going outside of the device. So that is open circuit type. So one way, but closed circuit type, you need to circulating used air and new fresh air. Okay, and then again, there is a hazard for diving. There is a pressure related problems. The other ones are carbon dioxide and oxygen, the chemical ones. But this one is a pressure related problems. The decompression sickness. Uh, this is coming from that super saturated inert gas, the air, comes out of blood in the form of bubble. So when the people or human is in the deep water, cold pressure is high, so that more gases are coming into the resolved into the blood. But when you come back into the surface, the pressure is lower down, reducing. Then the gases inside the blood is comes out of blood into a bubbles, and that bubble causes a problem. And inert gas, nitrogen narcosis, is because of the high pressure. It's high. That gives you a sense, loss of senses. So two cases, the bubbles coming from the blood and pressure in nitrogen. The only treatment coming from recovery is the recompression chamber. You should stay long time in recompression chamber. Compression regulated chamber. Saturation diving or diving bell, that is a high pressure. Compression chamber or recompression that treatment can be done in this kind of devices. Or it can be used for diving operation too. And submarines. Military submarines. Jangbogo class and Sononil class is for Korean navies. The small ones using diesel engine. Nowadays, we in Korea also had a 3,000 ton class new building of submarine in these days. So it's getting bigger. And Typhoon is coming from Russia. The nuclear power plant is 48,000 tons. It's a very big one. You can see that the length of them is Ohio class and Typhoon class have length of say 550 feet. Comparing to Korean Jangbogo is very short, it's less than 170 meters. So diesel submarine, Korean Navy only have diesel submarines. The diesel engine says you need to have air for the operation or explosion of or burning of fuel, so that they need to have come back to the surface to operate the engine. And that engine charges batteries. So battery has a short time to use. That is the main bottleneck for submarine operation. The battery is used for the electric motor to propelling the submarine and also submergence operation. So maybe can say several days is the only limit for the diesel submarine for the submerged operation. Comparing to the nuclear power plant, they can stay several months. So that is very important key features for Navy operation. Nuclear submarines, typical nuclear submarine can divide more than 1,500 feet, the depth, and travel over 60,000 nautical miles. It is about to rounding up the whole globe, Earth, one cycle, and before exhausting initial nuclear fuel supply. So you can say that they can stay as long as they want. But the problem is human. Human cannot stay longer under the sea. So there is a regulation that from the Navy of US Navy, probably 1 month is the maximum duration. I can't remember the exact number, but about in order of months. Otherwise, they should have a problem, a mental problem, also other health problem. It's not technical problem, it's human problem. They cannot stay longer. All right, here's one video.
A submarine has a sleek cigar-shaped body that enables it to move swiftly underwater. A pressure hull made of high-strength metal contains the submarine's crew, machinery, and most or all weapons, preventing them from being crushed by the pressure of the water at deep depth. A submarine has tanks built into the bow and stern called the main ballast tanks. The sections of the bow and stern containing the tanks are not usually surrounded by a pressure hull. In order for the submarine to dive, the main ballast tanks are flooded with seawater. The added weight causes the ship to lose its ability to stay on the surface of the water, and it submerges. Movable surfaces on the outside of the submarine control its movement beneath the water. These surfaces are horizontal diving planes and vertical rudders at the stern, and a forward set of diving planes either on the bow or on the sail structure. To dive, the diving planes at the stern are tilted down. As the submarine is propelled forward, the flow of water over the tilted planes causes the submarine to glide downward. The rudders steer the ship. Crewmen can turn a rudder to the left or right to make the submarine change course. To move the submarine upward, the stern diving planes are angled up. The diving planes at the bow or sail are used to help keep the submarine at a precise depth while near the surface, especially when launching missiles or when raising an antenna or periscope above the surface. To resurface, water is blown out of the ballast tanks by compressed air so that the submarine comes up through the water.
Right. Questions? May heard that the submarine is made of two layers of skin. The inside one is they call the pressure hull. The outside is we are seeing the outside hull. That is relatively soft shell. Inside the pressure shell is important because the high pressure coming from say 100 meter down is covered by that pressure hull. Right? Non-military submersibles, they say submersible or submarine. So it is people,
고객님들 주소 저희 성의로 등을 잡지 말아주시기 바랍니다.
수업 좀 듣겠습니다.
우량차는 13시 25분에 서울역을 거쳐 서울역으로 가는 KTX 자연입니다. 맞습니다.
okay, and then so that it is usually for tourist submarine. Go to the seaside, commercial, small tourist submarines to looking around under the sea, with fishy and other sea animals, plants there. Then there is also research submersibles. They are saying this is submersibles. It can be a commercial, non-military. Limited service range. Range means how far it goes for. So it is very small, like distance they can travel. Usually they have a cable connected to the surface ship, and so that they are transported area by surface ships. We call it a mothership. Submarine. And we already see this picture by say that this is a right hand side is Sinkai 6500 means deep ocean which can submerge depths of 6,500 meters coming from Japan. All right.
I have a question.
Question. Go ahead.
Yes, for the second last slide, yes, that one. How deep is surface vessel? Like how deep is area of surface vessel?
My surface vessel is the ordinary ship.
Okay.
They are just carrying, transporting this submersible.
Okay, thank you so much.
Submersibles is launched at the left-hand side. This is a shape of recovering the submersible from the sea to the ship again. The loading, unloading of submersible from the surface ship at the left-hand side. So it is a mothership. Okay.
Okay, thank you so much.
Any other questions? Oh, we can have a 5-minute break. We can restart at 1:30. Dajang will guide us the second part of lecture. Right? All right. Start again the class. Dajang already shared her screen. So, Dajang, are you ready to start?
Yes.
Okay, let's go ahead.
Hello everyone, I'm today's lecturer Da-Jung Kang. And today I'm going to talk about underwater system, especially unmanned underwater systems, which include ROV and AUV. So unmanned underwater vehicles are any vehicles that are able to operate underwater without human intervention. And these vehicles can be divided into three categories. First, remotely operated underwater vehicles, ROV, which are controlled by a remote human operator. And it's depending on the motions, it can be categorized as free swimming ROV and towed ROV and bottom crawling ROV, and autonomous underwater vehicles which operate independently or human input. And most of the AUVs move forward using propeller power system, but underwater glider use buoyancy. And there is also hybrid vehicles. Before learning about the ROVs and AUVs, let's see this degree of autonomy first. There are four.
Da-Jung,
Yes.
we cannot see your slide set. You're showing another video. Screen is showing. Sure.
Oh, sorry. Now it's good.
Right. It's okay now.
There are four levels of autonomy, and as the autonomous level goes up, human intervention decreases. At the low level, there is remote control, and in this level, seafarers are on board, and some operations are automated, and seafarers are can control for other operations. Next, on teleoperation level, seafarers can available on board to take control and operate using the sensor feedback. And from this semi-autonomous level, low seafarers are on board and human can control or operate things from another locations. And on fully autonomous level, the operation system can make decisions and determine actions by itself. Now let's see how the autonomous vehicles are advanced. At the first generation, people mostly focused in designing and implementing the vehicle, and those vehicles were at the low-level control like teleoperation, and it was a single agent system. And then at the second generation, vehicles were capable of autonomous interventions. So the task usually carried out by ROVs or human divers. And then at the most recent generation, a fully automated mission was available, and it enabled swarming operation and distributed control. Now let's take a look at the types of missions. There are three main missions: industrial missions, science missions, and military missions. In the industrial field, main mission is the hydrocarbon field development. The oil and gas industry uses UUVs to make detailed maps of the seafloor before they start building infrastructures at the subsea. And this video will show you about why do we need to use UUVs for industrial missions.
for these resources. Remotely operated vehicles, ROVs, are very useful in the oil and gas industry. They are robotic machines that can travel underwater to help with various activities related to subsea exploration and development. Why do we need ROVs? Divers exploring subsea environments for the oil and gas industry has its limitations. For one, there are risks involved. Secondly, going too deep inside the water might not be possible. Remotely operated vehicles, ROVs, are the solution to these problems. They make it possible to access the areas unreachable by divers. More complex exploration and development activities can be carried out with the help of ROVs. Repairs of subsea equipment would earlier require divers to venture deep below to examine the systems. However, this also comes with its limitations due to poor visibility and safety issues. Water currents, depth of the water, and subsea temperatures also pose serious challenge to underwater repairs. ROVs can even be used for repairs of equipment underwater, making the operation and maintenance of subsea equipment easier. How do ROVs work? ROVs for subsea activities have been seeing a lot of development since 1990, when highly capable ROVs started being used. ROVs remain floating in water due to the integrated buoyancy units built into them. Today we have modern ROVs that are submerged in the water in a cage, also known as a garage. They are tethered to the garage by an umbilical. When required, the ROVs are let out of the cage. They can travel for up to 100 feet while still being tethered to the cage. An operator, also known as a pilot, can control the ROV to get the desired work done and also ensure that the ROV isn't tangled in its own umbilical. There are
Okay, and people use UUVs for the science mission as well. Oceanography research and environment monitoring to study ocean, and bathymetric study to measure the depth of the water body. And the video on the right side will show you why do we need UUVs to explore the seafloor.
We not map the ocean floor at this point in time in history. It's the largest data gap, knowledge gap potentially left on the planet.
Bedrock is a company aiming to fix that. They're building ocean drones, or autonomous underwater vehicles, AUVs, to collect all kinds of data about the seafloor, and have a platform that makes that data easily accessible. Co-founder Anthony Damari says that surveying the ocean floor will be integral to life in the next 50 years.
It is unbelievable how little we know about the ocean in comparison to Mars or other planets.
This could touch the future of many industries, from energy, wind and oil, to more out-of-the-box ideas like underwater data centers. And right now, a big issue is being able to actually see and understand the physical space.
Right now, the industry is basically relying on these huge ships. The United States goal requires an unbelievable amount of surveying, to the point where even if we could allocate all of the survey vessels that we have now just towards supporting this activity, we don't have enough. That's a scary bottleneck to sort of realize. The second part of the equation is now we have this enormous geospatial data set that needs to be processed, needs to be organized, and it needs to be ultimately delivered to some end client or system to do something. In fact, it is likely and expected to be the largest geospatial data set on Earth. Just physically, think about it, it's 2/3 of the Earth.
Bedrock's ocean drones will be able to gather data not only about the surface of the seafloor, but also the layers stacked on top of each other.
At the moment, we make a lot of decisions without fully understanding the impact of exactly what those activities are doing and how that affects the ecosystem. Fundamentally, we're going to be living in a world where there's a lot more people, where we need a lot more food, where we need a lot more infrastructure that will rely almost inevitably on the ocean floor.
And for the military missions, we use UUVs for the ISR, intelligence, surveillance, and reconnaissance. The objective of ISR is to collect intelligence data above and below the ocean surface while remaining undetected by enemy. And it is used for anti-submarine warfare, which has 3 categories of operations. First core deadly risk, which is monitoring all the submarines that exit our port. And second, maritime shield is clearing and maintaining a large maritime forces operating area free of threat submarines. Lastly, protected passage is clearing and maintaining a route for a maritime force from one operating area to another free of threat. And it is also used to mine countermeasures. This is finding or creating areas of operation that are clear of sea mines without recurring and now let's see the different types of ROVs. For the class 1 ROVs, they only do observation. It is typically less than 40 kilogram in weight and fitted with inbuilt camera and lights. Blue ROV and boxfish and deep tracker are the examples, and they operate at the depths less than 100 meters. And then class 2 ROVs do observation, and sometimes they can carry some payloads. It's larger than class 1, weighing up to 150 kilograms, with multiple cameras and limited sensors. They are capable of basic physical sampling and observation. And then class 3 ROVs can do work. Their weight is up to 5,000 kilograms, and it is usually used in deeper water more than 300 meters. And let's see the one example of class 3 ROV. Kaiko 7000 is from Jamstec in Japan. Kaiko is mainly intended for deep sea surveys and marine resource surveys, which require heavy work. And this has several cameras and lights, so it can see underwater and assist in mapping navigation. Depth capability is 7,000 meters, and launcher weight is 5.8 ton, and beakers is 3.9 ton. Now AUVs. There are several types of AUVs depending on the range they can dive and their mass. The smallest one is micro AUV, which has fairly low range, but it is very light so that it can easily transport it to the water using hands. And then there is a portable AUVs. This is mostly used for research purposes or big mapping purposes. And then if we move to here, survey AUVs. This is mostly used in oil and gas development. Another type is long-range AUVs. And this is for the research purposes, but with more longer missions. And then all those AUVs that I just mentioned, they use propellers to move forward. However, gliders, they use buoyancy engine, so they can ascend or descend by changing buoyancy by an oil bladder. And this is the example of Toadfish AUV. Yeah, this video will show you one type of Toadfish AUV.
On board the RV Resolution in the Boston Harbor, we've come here to see for ourselves how the Bluefin AUV operates.
AUVs like the Bluefin 21, they're the tool you would use to conduct a wide area side scan survey in ultra deep water.
Will O'Halloran is a marine operations engineer for Bluefin Robotics, which designs and builds these autonomous underwater vehicles in Quincy, Massachusetts.
If this were a mission, a real mission, what would it be doing?
So the next thing that would happen is the radio instructions we received to that red antenna there. The vehicle would say, okay, I'm going to start this mission. The propeller would spin up and then it would dive.
Here in the Boston Harbor, the water is only about 40 feet deep, which is easily manageable for the Bluefin because this autonomous vehicle is used to working in depth several miles below the surface.
The Bluefin 21 can dive about 2.5 miles, but Flight 370's wreckage in the Indian Ocean may be deeper than that. It takes about 2 hours for the Bluefin to reach the bottom, where it can operate for another 16 hours. It scans the ocean floor as if it's mowing a lawn, using side-scan sonar, which identifies objects that stand out from the seabed.
When it's working with the side scanners, it's not actually taking pictures, right?
No.
It's measuring sound.
Correct. What it's doing is it's converting sound to electricity and then turning that electrical value into numerical values, then turned into an image.
When it returns to the surface, scientists download the sonar data to computers. The results may look something like this.
And what we're looking at here, for example, this is a shipwreck in Boston Harbor, so you can see how it's different than the area around it. You can see there's parts of the steam engine right there. And
if something catches their eye, the Navy will send down a high-resolution camera on the Bluefin 21. It can take black and white photos covering about 15 square miles a day. It's a slow process, moving at just 3 nautical miles per hour, only made worse by horrendous conditions, freezing temperatures, mountainous terrain, and complete darkness. But even diving blind, there is much hope the Bluefin 21 AUV will see something. Randy Kay, CNN, Quincy, Massachusetts.
And then I brought another example of Toadfish, Odyssey 2. This was developed by MIT in USA. And this is a self-contained underwater mass spectrometer system. And this system can be applied to the pollution monitoring and fundamental or system research. It has maximum diameter of 0.58 meter and length of 2.2 meter. Weight is about 200 kilogram. The maximum operating depth is 3,000 meter with endurance of 8 hours. This video will show you how the glider works, but because of the time, I will just skip it. If you want to see the video, you can just use this link. And then this is the example of glider. Sea glider is developed by Kongsberg in Norway. And it is for continuous and long-term measurement of oceanographic parameters. Its dimensions are like this, and the maximum operating depth is 1,000 meter, and it has really high endurance of 10 months, but it's depending on the configuration and sampling rate and operational area. Yeah, that's it, and thank you for the listening.
Okay, any question to Dajong? No. I saw that you improved several new slides. It's good. So could you share the slides later on Kakao talk?
Yes, I will share the.
Also, Youngmin, the Tuesday lecture material also please share with us.
Okay.
Right, thank you for your lecture. And then we move on to Pierre for discussion session. Okay, Pierre, are you ready for discussion?
Can you hear me? It's okay?
Yes, yes.
Perfect. I will just share my screen. So hello everyone, I will make the discussion today about underwater system. Of course, we are online, but feel free to ask any questions and to participate. So first, we will have a little quiz about some funny stuff and historical events about underwater systems. And after, I have 2 or 3 questions to ask us and to brainstorm about that. So first, we are going to make a quick quiz. So just let me. Okay, it's loading. So here is the pin code of Kahoot. You can do on the app or just going on the website kahoot.it, and I wait for you to join. So does anyone who wanted to join has reached? I will, okay, it's still coming. I wait a little bit. Okay, so I'm sorry for the other one, but it's only the free app, so I cannot have more than 20 people on the room. Sorry, I didn't were aware of that. So let's begin. So be ready. So underwater systems. So I remind you just the rules of Kahoot. You have to find a good answer and as quick as possible. And after we'll see the rank of the best player. Okay. Okay, let's go. First question. How did the first autonomous submarine to generate oxygen? Okay, yeah, it was a hard question. In fact, so it was thanks to Salpeter. So in the picture, you could have seen the Dribble, which was the first autonomous submarine. So that didn't have to be linked to the surface to have oxygen. And so with a chemical reaction with Salpeter, the Cornelius Dribble reached to create oxygen. So it was an archaic technique, but it works. So we'll see who are the first. Okay, so Sangwon is leading right now, but we'll see at the next question. So what was the name of the first military submarine? Don't be shy, answer. So yes, it was the Nautilus. So the picture that I chose was totally a fake one. It was really a little submarine. And I have a picture, I think. Yeah. So it was made by Robert Fulton in the 19th century for France. So Robert Fulton was coming from the United States, but France first have support his research, and then it was a United Kingdom. And this is the official first submarine, a military one, because it was the first which had destroyed a ship. He just stick a mine on ship. So true or false, the Soviet Union and the US Navy has trained cetacea for military purposes. So true is the blue and false is the red one. Yeah, so it was true. In fact, a lot of army in the world are using cetacea and train them for military purposes. It could be for observation, surveillance, or for mine countermeasures. It really depends. So now who's leading? Lou is the first one. Great. So two more questions. What animals do the US have studied to create specific spice submersibles? So for the people who don't know these comics, it's a strip who is coming from Belgium. It means Tintin. It's really well known in France. Okay, yeah, it was sharks. I didn't find any picture of this kind of project, but I found some information about that. And they tried to create a submersible who just looked like a shark to go spy the Soviet Union. And Lou is still leading. Maybe only one question to be better than her. So on the picture, there is something. Is it a ROV or nothing? Another thing. So like before, true is blue, red is false. So ROV, it's a remotely operated vehicles. Yes, it was, because we can see the link until the surface. It's not an autonomous underwater vehicle that we have seen just before with the lecture. So the final list, the podium. Third, Seung-Yoon, John O, and the last. Yeah, it's Lou. Well done. So thank you for your participation to the CAUT. Let's go back to the slides. So I will ask you just one question. We have seen through the history that first in this quiz there was manned submersibles, and after men were trying to create unmanned underwater system. So do you know why, and do you recognize this picture?
The Titanic thing?
Yeah, And do you know what happens this summer to this submarine?
They were unable to withstand under the water pressure.
Yeah, exactly. So this was a main submarine that was used to go to visit the Titanic underwater. And as you said, it was not strong enough, so it just collapsed. So it was a tourist one, but it really raised the question that it's really dangerous to make submarine with people inside. So let's just have a bit of discussion about that. So according to you, what are the advantages of being an unmanned underwater system or having humans in? So I wait for your ideas.
Maybe there's a less risk involved.
Okay, for which one?
For unmanned.
Okay.
You can manually control submarines if you have people inside.
Yeah, okay. Okay, right. Okay.
If it's unmanned, maybe the system can be smaller.
Yeah,
and
okay.
it's better for some purposes.
Okay, other ideas?
The unmanned vehicles or submarines are also, I think, cheaper because they are smaller and you don't have to have all these safety systems.
Yeah, clearly. It's a good argument for them. Maybe
And
we
on
can
the other
find.
side,
Yeah,
okay.
go ahead. Go ahead, yeah.
Go ahead.
Okay, so just I was saying we can maybe find some other advantages of having humans, or you just find one and it's okay. No?
I think it's really hard to communicate with the submarine, so you really don't know what's going on there if you're not down there. So the advantage of having humans there is basically the same as the first point, but you also know what's going on.
Yeah, exactly. That's one of the key aspects for making unmanned underwater systems. You have to have really good communication to see if there are any problems that happen inside, and having humans, definitely it's more easy to manage that. Okay, so yeah. So we can find that they both have advantages, but having unmanned underwater systems could save a life because there are less risk involved. We have smaller devices, and also it's cheaper, so it's really interesting for a lot of purpose. And now we are going to talk about the impact of the unmanned underwater vehicles on the future of war. So we have seen and listened that there are military purposes, and with the Ukrainian war, it's really the beginning of the use of unmanned vessel. So first, this picture is an Ukrainian unmanned surface vessel, so not an underwater system. Its range is up to 800 kilometers, and its price is around 200,050 US dollars. And now we compare to the future vessel that will use Ukrainian forces. So it's called Marishka. It's new. It has never been used yet in the war. So we can see that it's a bigger one with a range that is more higher, but the price is also more expensive. So what are the pros and cons for the use of automated unmanned vessel as vessels for in the army or in general, but my examples were based on military ones.
It's safer because there is no like soldier in it.
Okay, yeah. Yeah, clearly. But don't you think that it could not be also a disadvantageous to don't have real people inside?
Yes.
But we will see after. Does anyone else have some ideas about that?
Maybe it can be smaller and less detectable.
Yeah, clearly.
Also, we don't need to care about the oxygens for the human, so it can be a little bit more cheaper.
Yeah. Yes, clearly, that's one of the biggest issue about underwater systems. When you have humans in, you have to have good oxygen management. So when it is unmanned, it's really easier to make.
But at the same time, developing the system of the AUV can be expensive, much more expensive than just training the one person who needs to drive the AUV. So maybe there's a disadvantages.
Yeah. Yes, clearly. But I don't have thought about, but I only took example about unmanned vessel for the last picture, but we could say that the price of a military submarine could be really close to 100 millions of US dollars. So in fact, it's not a real disadvantages because in the end, unmanned vessels are really less expensive. Do you have any other idea about that?
For disadvantage, it's hard to communicate with the AUV.
Yeah, clearly. For example, if you are using an AUV and that is targeting the wrong ship, it could be impossible to make it stop if it's an autonomous. So you could have casualties in your own team, and it should not happen if you have soldiers in, of course. Okay, that's good. And I have one final question. So what will be the future evolutions and missions for underwater system, and especially the unmanned the autonomous underwater vehicles? And not only in a military field, think about all of the kind of mission that we could have already seen in the previous lectures, or that you are thinking about.
Maybe I heard about a NASA program where it would send a submarine on Titan. So that's one of Saturn's moon.
if I remember well. Okay, great. I didn't know that.
Let's tighten.
Yes, of course, we cannot do that with a main underwater system. It will be too hard to make. Okay, any other ideas? Maybe in science field, ocean exploration, or ideas like that?
Maybe underwater systems could be used to find oil or ore in the water and in the sea.
Okay, yeah. Okay. So yes, like we have seen in the lecture of Dajon, it's really easy to use ROV or AUV with a lot of vessel that you could not do that with humans on it because it's really more expensive and time consuming. So it could be a good idea to explore and find new resources. Any other ideas? Please feel free, even if it's not a common idea. So, okay, I think that that's all. So yeah, I think that personally, in the future, we'll have biggest fleet of AUV that could be helping us in military purpose or only for science, as we have seen in the previous lectures. So it's really a device that is not really developed right now, but in the future, it will be really crucial for scientific breakthrough. So thank you for your participation. Here are my references if you want to check some facts. And thank you for you.
Thank you.
All right. Thank you very much. This interesting and live and discussion session. Kahoot is interesting too also. All right. That's it for today. So next week we will have a some project presentation. Okay. Also, Pierre, can you share your slide set at the Kakao for class?
Yeah, of course.
Okay. All right. Thank you for attending and lecturing and discussion. And see you on next time, next week. Bye now.
You.